So, dear friends, let us solve this problem. This problem is uh, related to equilibrium of system of coplanar forces. The problem statement is a lever AB is hinged at C. Here at C, and this is the lever A B and attached to a control cable at A. So this is the cable, okay, it is attached with the this cable as shown in figure. If the lever is subjected to 25 Newton vertical force at B, so this one 75 Newton, it is vertical force. Determine the tension in the cable and the reactions at C. So at C, here the support is at C, support is hinge support, hinge support. Okay, so the reactions will be the means in a uh, vertical direction and a horizontal direction, like at C, this is C, and then suppose this one B C and H C. Okay, so let us draw the free body diagram for this. So what will be here? It is A, it is B, and at B the load is vertical 75 Newton, and vertical of what? So at C the hinge is there, so that's why this is VC, and this one, for the more clarity, let us this one, it is HC. So as the hinge is here, you can see how it is acting. It is not inclined, however the lever is inclined. Which is inclined? This is the lever is inclined, okay, and how much inclined? It is 20 degree. You can see here, if you see the figure here, 20 degree it is inclined. Okay, and hinge support we have removed, and this is the cable, and the cable in the tension we are showing T. So here in this figure we no need to bother about this hinge because it is connected with the cable, and then we have to take only tension. Okay, now what about this is inclined with 20 degree. 20 degree. So let us draw the perpendicular to this vertical load 75. So it is here perpendicular, so this angle will be 70 degree. Okay, what about the if we as this lever is inclined, okay, and suppose this we draw a line, this one and this one, okay, so this one and this one both are parallel. Okay. So what about this angle? So this angle, and this is it is perpendicular. This is perpendicular. It is perpendicular to this. Okay. So this angle is 70 degree. So this angle will be 20 degree. Okay. So however, this 75 Newton is parallel to this one. This one, okay, this 75. Let us extend it. This 75. Okay, but if we see how it is inclined, this lever, so it is 20 degree inclined, and suppose we extend the line from A so that we can get the inclination of this T. T is here inclined, and 75 Newton is also inclined with this line. Okay, and this one and this one both are parallel. So this inclination we came to know, and next we have to know about inclination of this. Okay, and so what we have to do for this, let us draw from here. Let us extend it so that from here this line and meet this. So it is meeting at here, and suppose giving the name D, and this angle is alpha. So if this angle is alpha, so this one and this one both are parallel, so this angle and this one is common, so that's why this one will be alpha. And what about this angle? So this angle, this will be perpendicular to this. Here it is perpendicular, and this angle we know it is 20 degree. So if it is 20, then this angle will be 70 degree. And what about this angle? So suppose it is theta. So in this way, we have drawn the FBD of the given force system. Now what we have to do, as per the question, we have to find out T, also HC and VC. What? So for that we need to know the inclination of this T with this lever axis. So that inclination is theta. So theta, before that theta we need to know. So how to know it? Because there are two unknowns are there, alpha and this theta, and only one angle is known here. And what about the dimensions? So here this is 150 mm, and this one is from here to here, it is 100 mm. Okay. So what we have to do, because theta is also known here, alpha is also unknown, and let us draw it separately. And this is 100 meter, 100 meter, this what, this one, this is the A, D, C, this angle we don't know, this angle we don't know, and AD, the length of AD dimension also we don't know, don't know, but that can be known by, if you see in the triangle ACD, and this is 70 degree. So by cosine rule, and that is AD is equal to this one dimension AC square plus AC square, and this is also known here, this one is 120 mm, it is given, this is also given. Okay, so AC square plus CD square and minus 2 AC multiplied by CD, then cos 70 degree, and it is under root. Okay. So AC is equal to 100 square, and CD square 120 square minus 2 multiplied by 100 multiplied by 120, then multiplied by cos 70. So by solving it, what we get? We get 127.25 mm. Okay, so AD is now known. So what we have to do? By sine rule. So what is the sine rule? So here AD, if you take AD, so opposite angle, that is the here opposite of this one, this 70 degree. So sine 70 degree, and let us put the value 127.25 is equal to this. We want to know. So opposite of theta CD, and CD is equal to 120 mm. Okay, and it is equal to CD 120 divided by sine theta. So from here we can know the theta is equal to, we get 62.39 degree. Okay, and what about from this figure? Alpha is equal to what? So alpha is equal to 180 minus this 70 degree minus this theta 62.39 degree. So what we get? It is 47.31 degree. So alpha is equal to 47.31 degree. Theta is equal to this one. Okay. So what is next? So coming to after this, after this, this free body diagram with the help of the FBD. So at C, how many forces are acting? So two forces are acting. At A, one is acting. At B, one is acting. So better to take the moment about C. Summation of moment about C is equal to 0. We are taking here. Okay. So you can see here, and this clockwise we are taking positive. So the 75 Newton, this one 75 Newton, which is inclined by 20 degree. Okay, however itself it is vertical, but with respect to 75 Newton, let us note 75 Newton is vertical with respect to lever, but with respect to the support reaction we see, it is inclined with 20 degree from the vertical. Okay, means for that this one, this one, this one, this one, this is 75 Newton. Okay, so this one, this angle here is 20 degree, and this line is parallel to VC. Okay, that's why the moment about C, if you take, so here 75 Newton, and it is acting, it will try to rotate the lever clockwise, that's why positive, and 75, and it is there is inclination of 20 degree with the vertical. Okay, so with the vertical, that's why sine 20, and then perpendicular distance we have to multiply. So perpendicular distance, if you see the free body diagram, okay, so this is the perpendicular distance, and that is 150. And what about the next, if you see the tension, so tension T, it is anti-clockwise, that's why minus, and T inclined with the vertical with alpha degree, that's why sine alpha, and alpha we know, and multiplied by, it is this one, the perpendicular distance is now this one, means from A to C. If you see the free body diagram, so it is 100, okay, and then is equal to 0. So from this, as we know, alpha is equal to, if you see, so alpha is equal to 47.31 degree. It is 47.31 degree. So from this equation, if we solve that, so what we get? We get from that T is equal to, it is 119.3 Newton. Okay, so out of 3 unknowns, we have found out one, that is T, tension in the cable. To get VC and HC, we need to apply the other equilibrium conditions. To get these, summation of fx is equal to 0, then the same, what we have to do, the reaction, and the reaction we have taken in negative direction, so that's why HC, and the we have to take minus SC plus this T, and this T is vertically it is inclined with alpha degree, so that's why sine alpha we have to take, and t already we know, alpha already we know, alpha is equal to what, 47.31 degree, and t is equal to 1193 Newton, and this equal to, it is 0. Okay, why we have not considered 75? Your question may be 75 Newton is why not considered. So because it is parallel to VC, means vertical. Here it is vertical, means vertical, that's why. And from this what we get, so we get HC from the equilibrium condition, and this equation HC we get 88.11 Newton. Now applying the summation of y is equal to 0, so what we will get, so the VC reaction at C, vertical reaction, and the load 75 Newton, that is acting downward, and then this one T, and T is inclined here, and the direction you can see here. So T is inclined this T, and vertical direction, so it is acting downwards, that's why minus T, and with the vertical it is making angle alpha. So what about with respect to horizontal? So that will be cos alpha is equal to 0, and T is known, alpha is also known. Okay, so from here VC we can get 155.43 Newton. So summarizing the answers here, T what we get, so T is equal to 119.3 Newton, and VC is equal to 155.43 Newton, and HC is equal to 88.11 Newton. So this is our answer. So how to get this answer? Once again summarizing, as per the question, the lever, this lever is inclined with a 20 degree, and this is acting, this 75 Newton is acting vertically, and see here hinge is how it is the means it is whether inclined or not. So it is not, hinge is not inclined, that's why the force means the reactions VC, it is acting vertically, and this VC and 75 Newton both are vertical, but 75 Newton itself with the lever, okay, so it is not with respect to lever, it is not vertical, because lever itself is inclined by 20 degree, okay. And one more thing, the cable is the lever is supported by this cable, okay, and the cable itself is supported by hinge. So whenever there is a in question the cable is there, then cut the cable, okay, and no need to worry about the to include the support reactions of the hinge here, okay. So after cutting, only T we have to consider, the tension we have to consider, okay. And what are the unknowns? So obviously this we got from the calculation, 70 degree, and this with parallel to this line, how T is inclined. So with this is parallel, so this angle, and if you know this angle, so this angle, this we have taken alpha, that's why this will be also alpha, okay. And suppose this we take theta, so there are two unknowns, okay, and two unknowns, so how to get the one of the angles, then others we can get. So for that we had applied the cosine फार्मूला, ठीक है. सो इससे क्या हो जाता है, इससे हमें जो भी साइड इन द ट्राइंगल अननोन हो वो